Hi, I'm Tommi Saxelin from the big C, Cisco. And yeah, it's a good question, whatever the massively scalable data center might mean. It was actually a topic I spotted on the suggested topics agenda, or the list of suggested topics, and I chose to pick that one because there's been some discussion within the big C about massive scale in the data centers.
Excuse me. I'll just see if I can get rid of this thing.
Sure. So, what I'm going to talk about is the real massive scale, so what is really a big data center. But then, because that's not really that interesting to all of us, I'm also going to talk about not that big data centers, a bit smaller data centers, but scalable still, and the issues related to that. And of course, no presentation about data centers nowadays is complete without a slight touch of software-defined networking. So I'll just brief you very quickly on what Cisco is doing on the SDN front, because with some of you, I saw a good smile there. With some of you, I've discussed this topic before, and somewhere in the past I was saying that Cisco doesn't really see a role in SDN. Well, now I'll explain what Cisco's role in SDN nowadays is. Well, let's start with definition. Why do we need massive scale, and what do we mean by massive scale? This is a very, very simplistic view of the internet. All of you guys know what the internet looks like a lot better than what this picture is trying to represent. Anyway, you have the custom IP network, you have the ISPs, you have the exchange points, you have some transit networks, some backbones, and you have data centers all across. This is the textbook, this is what it used to look like, and this is what the basic data center technologies are geared towards. The thing, or the area where the massive scales comes into play is these guys. The hypergiants, the Googles, Facebooks, Amazons, Microsofts of the world, who really are offering services not only to their local IP networks or to their end customers, but everyone in the world. We call these the warehouse scale data center players, and their customer base is not only tens of thousands end users or hundreds of thousands end users or even millions of end users, but hundreds of millions and billions of users that they need to serve. And these guys are the ones who need a massive scale in the data center. So I'll touch on what they are doing, but then I'll focus on a bit of a smaller scale, what we guys are most likely doing in our data centers to make this a bit more relevant to all of us. Those of you who come from these hypergiants, well, you know better what you are doing than I do anyways. So what is massive scale? Well, that's one definition, the customer base you are serving. The other one is how big your data center is. And what we are basically saying, or how Cisco is drawing the line, this is definitely not an exact figure or an exact science, but up to about 30,000 physical hosts or Ethernet ports, even 10 gigabit Ethernet ports, you can scale with traditional technologies, traditional topologies. Of course, depending on what you're doing, you might have to do some things differently, but this is a generic figure. So the real massive scale, if you have less than 30,000 ports, what I'm going to talk to you about next, about the real big scale, doesn't really apply. But then as we get to smaller figures, less than 30,000 ports, talk about thousands of Ethernet ports, 10 gigabit Ethernet ports, then we'll have a discussion about that as well. So, how do these guys build their services? Well, of course, as I mentioned, the hypergiants, they are servicing millions, hundreds of millions of customers, and they are running tens of thousands of servers. So their computing paradigm is, it's not the usual one, or the enterprise paradigm, where the focus is on virtualization and how do we virtualize. Their paradigm is on how do we scale this thing horizontally, how do we do distributed computing. And you know how they are building their computing algorithms. They are building large Hadoop clusters, they are using MapReduce algorithms, all that sort of stuff. And in those types of distributed computing environments, horizontally scalable environments, what you actually end up having is an environment where there is a lot of server-to-server traffic. And therefore, they need to think about the topology a bit differently than the traditional Cisco textbook may have taught back in the 90s. We had the core, we had the aggregation layer, we had the access layer, and it was spanning tree all the way through one path across the network, the score. Well, that doesn't apply to these types of environments at all. This is a diagram of an actual large-scale distributed computing data center environment, one of these hypergiants that has deployed Cisco. Well, you may know which of these big players has not deployed Cisco or any other commercial vendor, so you can maybe guess where this might be. But what they have here is a sort of a fat tree slash hyper tree topology, where they have a large spine of, you could call them core devices or spine devices, and then leaves of, well, maybe they should be called leaf devices rather than aggregation devices. And then they have their top of rack switches where they connect 40 physical servers in each rack. As you can, well, you can't really see it, it's so small, but these boxes here are Nexus 7010s. If you know the Cisco product portfolio, that is a pretty big, refrigerator-sized 10 gigabit Ethernet switch with 40 gig and 100 gig modules available for it. So their spine is a bunch of Nexus 7000 switches. So that's a heck of a lot of 10 gigabit Ethernet ports. In their leaves and in their top of rack, they are actually using Cisco Nexus 3000 switch series, which is, if you know the product, it is a merchant silicon-based Cisco device that does very low latency 10 gigabit Ethernet at a reasonable price. Well, everything's reasonably priced, but you know how it goes. Yeah. So what this gives them is quite a massive scale for the server. So they can actually run thousands or tens of thousands servers in their environment. And with this kind of an architecture where there are a bunch of links across and a fat tree or hyper tree topology, they can scale quite nicely in this distributed computing environment, scale the workloads across horizontally, and have low latency server traffic, lots of bandwidth going on between each of the server hosts in their data center. Now, an interesting area of research is what's happening in that type of a network. Of course, the design start point is that we have a lot of server-to-server traffic going on. We are saying that about 70 to 80% of the traffic in the network is actually from one server to the other. So we need a lot of bandwidth between the servers. However, what the reality seems to be, depending on the environment, is that it's not that big a percentage. So in some use cases, well, notably in this one, this commercial player, one of the hypergiants, noticed that they actually have over-allocated bandwidth for the server-to-server traffic in their data centers. And that means that they've under-allocated the traffic from their end clients, well, it's probably here, from their end clients to the environment. So there's research going on this topic, and it will be interesting to see what comes out of it. What is the suggested model? Well, now I know that these fat tree, hyper tree topologies, there's been quite a lot of discussion, especially in the blogs, about this. Some of the data center gurus, they've been really interested in massively scalable data center designs, and they've talked about these topologies. And the result is that I've seen customers in Finland, planning on implementing this type of a topology with, 100 server, well, not maybe 100 server pods, but less than 1,000 server pods. So a few hundred server pods, with the thought in mind that our data center is so big that we need this type of an environment. That's not really the case. So in reality, this only applies, at least at the moment, to the hyper giants, the big players, the Amazons, the Googles, the Microsofts, and so forth. What about the rest? What about me as a Finnish guy trying to sell Cisco boxes to Finnish data centers? What am I talking about? And how am I solving the problems in the regular data centers? Well, the scalability problems in our scale of data centers, now I'm talking about Finland locally, our scale of data centers is actually a layer 2 scalability problem. And it's not a distributed computing paradigm that we are talking about, it's a virtualized computing paradigm we are talking about. And the things that present themselves as problems are things like MAC address scalability. We are running thousands of virtual machines in a data center, so we are running into issues with MAC address tables on the switches not scaling. And we are running into problems with the plain old layer 2 topologies where we are using suboptimal paths, not using all of the capacity we bought, having convergence issues and that sort of stuff. We do need layer 2, especially in the virtualized environment for virtual machine movement, vMotion, what have you, but the traditional ways of scaling layer 2 are not good enough. So the Cisco solution, Fabric Path. You may have heard about Fabric Path. Some people may have told you that Fabric Path is Trill. Well, it is like Trill, but not Trill exactly, and I'll explain why and how. What it is it's combining switching and routing basically. Doing IS-IS switching, IS-IS routing on a layer 2 environment, in switching environment. And the marketing name for this is Fabric Path. What it does, it takes a topology, any topology, and shows it to the rest of your network as one big switch, basically. Of course, from a management point of view, this is not one switch. You will have, if in this scenario, you'll have 8 devices that you'll need to manage separately. But from the topology point of view, from the traditional Ethernet point of view, the whole switch set up here, the whole topology looks like one big switch that takes care of, it is like one switch. The word arbitrary here is in bold because that topology can be basically anything. So you can cross-connect these switches however you want, as long as you configure those links that are connected to the other switches as Fabric Path links. And because of IS-IS running then within that Fabric Path fabric, we always make sure that the path we take across that fabric is the most optimal one. The nice thing about Fabric Path is that it scales to very, very large numbers of MAC addresses. This is not the case in Trill. The standards-based Trill requires each switch in the fabric to learn more or less all of MAC addresses in the fabric. With Fabric Path, we are doing what we call conversational learning, which means that the devices that are not directly connected to the end hosts that are involved in the conversation. They don't need to learn those MAC addresses. So basically, there's virtually no limitation on the number of MAC addresses. So it can be a very, very large layer 2 fabric because of that. And because of it being based on a dynamic routing protocol, ISIS, and because of the scalability or the ease of configuration, it's quite easy to scale. If we need more bandwidth, we add more links between the switches, and we add more spine devices into the environment that cross-connect this whole environment. If we need more ports, we add more access switches or leaf switches to the network. So it's a pretty simple way of building a modern, big layer 2 fabric. This is an example of a smaller scale deployment, about 2,000 access ports, 10 gigabit Ethernet ports. In a traditional environment, to get the scale we need, we would need to have 74 managed devices. Well, if we build it with Fabric Path, there's only need for 12 devices. Thanks, Kalle, for the warning. It would have been terrible to see you walk out if you hadn't told me that you have a call coming. So, a huge reduction in the number of devices and an increase in bandwidth. Plus, it will be a lot simpler to manage, just as an example. Some quick comparison between Fabric Path and Trill. I think the main point is the fact that in Trill we are not doing the conversational learning thing, which means that we will have just a basic standards-based Trill approach. There will be difficulty in the MAC address table scalability. The other one is that VPC Plus is another Cisco term, Virtual Port Channel Plus, which means that in a Fabric Path environment you can dual home your servers or your edge devices to the Fabric Path network. So kind of like multi-chassis. Well, yeah, you can multi-home stuff. In Trill, that's not usable. So it's not the same as Trill. It's basically using the same paradigm to do the whole layer 2, layer 3 combination, but it is, it's a Cisco technology, and as the name says, it's marketed by Cisco. An interesting use case I came across is an internet exchange point, and I was thinking whether Axo would like to take this into use in Tampere. I don't think this is really the issue in here. Scale to thousands of ports. Not really an issue here, but I would say that if you have an internet exchange point and you do come across a situation where you need thousands of 10 gigabit Ethernet ports and grow larger than 1 or 2 boxes, then this makes sense. So I guess there are internet exchange. Well, I know actually there are internet exchange points where this is needed, but it is a pretty large scale implementation anyways.
I think you should not underestimate your customers.
I'm not definitely. So come and grab me at the coffee break to talk about 8 Nexus 7000 boxes, and I will be happy to discuss. Actually, we are doing that with smaller boxes as well, and there are implementations, service provider implementations in Finland and in the Baltic region where they are running Fabric Path in a live data center network environment. There are big implementations, of course, in the US, but also quite large ones in Europe, and the ones in Finland and the Baltics are actually pretty big as well. So they are spanning the whole data center, covering everything. So if you want to talk to people who have this up and running live in their network, we can sure arrange those discussions, unless they are a heavy competitor of yours, in which case they might not want to share their secrets with you. Quickly about SDN. Yes. Well, what Cisco is emphasizing when we talk about SDN is that the keyword is programmability, and there are a number of ways of doing it. You can do it by taking, you could say, taking the Apple iPhone approach. So building a sort of a closed device, a closed ecosystem where you control, you control the device. As you can see, I'm controlling a pretty old one. You control the device, the operating system, the APIs, and the App Store. So that would be, vendor A would be Apple controlling the whole ecosystem, then opening up through their App Store certain set of APIs to enable people to write apps to this piece of hardware and to this ecosystem. The other way of doing it is, you could say, the Android way of running things. You have the you have the software by one vendor, Google defining what Android operating system is, and then you have a number of manufacturers building the devices themselves. And then the applications can utilize that. So if this was the iPhone approach, this would be an Android device approach. And then there's the virtual overlay approach, which would be like Skype running on either iPhone or Android. A virtual overlay where you have some basic infrastructure yourself, but you don't really care about what the devices are underneath. I'm talking about phones you notice, because I don't want to mention what the vendors are, whose vendor A might start with a certain letter, whose vendor B, and so forth. So vendor A, a pretty close ecosystem. Vendor C, a virtual overlay type of approach to programmability. And then basically the OpenFlow guys, Open Networking Foundation with their devices and so forth. Well, if you had asked me 2 years ago what's Cisco doing about SDN, I would have said I have no clue. We don't have a clear strategy. Well, now we are saying that our approach is and. You can choose what you want to do. So we'll support all of these approaches. Cisco being rather big, we can, move on multiple fronts and take multiple approaches. So how this is turning out in products, well, there will be a Cisco branded SDN controller and OpenFlow agents on some of our switching platforms. However, our positioning is that it is more a research platform than a platform you'd deploy into your, let's say, your service provider network, at least at the moment. So yes, Cisco is part of the Open Networking Foundation, and we will build support for OpenFlow. We have actually built support for OpenFlow on some of our switching platforms, and that's continuing. On the the iPhone approach, we have opened up a platform APIs. It's under the heading Open PK. Sorry, 1PK, Open Network Environment PK for application development. So if you are running an NXOS network, you can do this programmability thing on the top of the APIs we are opening up. And on the third front, Cisco's virtual overlay is built on a product that was launched a few years ago with the name Nexus 1000V. When it was launched, it was VMware only, and it was basically a replacement for the distributed virtual switch on VMware. Well, nowadays we still have the same name, Nexus 1000V, but that's basically just a platform name, and it runs on multiple hypervisors. So you can run Nexus 1000V both on VMware and Hyper-V and KVM and Xen in the future. The three first ones I mentioned, they are supported already. And what you can do with that is a lot more than just have the distributed virtual switch. You can, for example, run a VXLAN gateway, which enables you to basically stretch your layer to, tunnel your layer to across to, from your customer network to your service provider cloud, or from, if you look at it from an enterprise customer's point of view, you can extend your cloud, your layer, your private cloud from your data center to any service provider by running this Nexus 1000V in that environment. So Cisco's approach again to SDN is that yes, that's where the networks are going. The key word is programmability, and at least at the moment Cisco is embracing all of these different approaches towards SDN. What comes out of it, we'll see. For example, on the controller agent piece, we are still taking the first steps. So by no means are all of our platforms ready or open for open flow agents at the moment. But it's work in progress, and it will be interesting to see what comes out of it. So that's it. Any questions about massive scale, a bit smaller scale, or SDN?
One question over here.
I have one question. Is that is the first Cisco presentation I hear where you don't mention almost anything about FPGAs and the real hardware. So, are you a software or hardware company nowadays?
That's actually pretty interesting.
It's very philosophical. Be careful.
Yes.
They were an abstraction company.
Okay.
No, we actually had, every year we have a global sales meeting. As you know, all big American sales organizations have this. And it was interesting to hear in that presentation John Chambers, the Cisco CEO, positioning Cisco as a software company. But he did not forget to mention the ASICs. So Cisco is a software company that has very strong experience in ASICs and hardware design, so we can deliver the whole stack. That's basically the message.
So it's a post-hardware company.
Yeah, that's good. Post-hardware company.
Any other questions?
Beth was doing a great song with the singing, so moottoritie on kuuma, anyone? Cisco tahtoisin jäädä. No, I won't be able to stick around for sauna because I actually am starting my holiday today, so sorry about that. I need to go and pack and get to the airport, but it would be great to...
I don't see the conflict there.
Not you, but the wife does, so...
Those guys.
Why didn't
Yes.
you bring her here for the...
Yeah, for the sauna. Yeah, that's a good idea. I'll do that next time. Okay, thank you.
Okay, thank you very much.